pressing the floor when I open the door for her. She acting like a whore and I'm a letter. Learn from Project Pat.
Hello and welcome to the concepts video on addition and subtraction identities. So we're just going to jump right into it, and I'm just going to list the identities as they are. Okay? So the first one is going to be the difference or subtraction between two angles. Okay, and we're going to take the cosine of it. So this is given by the formula of cosine. So this is called alpha, just by the way. Alpha, and this guy here is called beta. They are Greek letters. Okay, so cosine of alpha minus beta is equal to, there's a formula which says this is equal to cosine alpha times cosine beta, and then plus sine alpha times sine beta. There's also a formula for the cosine of the addition between, or the sum between two angles. So let's say you want to add two angles together and then take cosine of it. Then this is going to look exactly the same, except for the sign in the middle is just going to change. Okay, so now we'll have something that looks like this. Alrighty, so those are the cosine ones. That takes care of cosine, the difference between two angles, and the sum between two angles. Okay, I usually remember these cosine ones as kind of just like, you can think cosine, 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 just because, and I'll show you why. This is what I think, just like a little thought bubble over here. Just because we have cosine of something, and then you see cosine, cosine right after it for both of these, okay? And the signs are actually different. Not the S-I-N-E signs, but the S-I-G-N signs, like positive or negative. So when you have a difference, or like subtracting, when you're subtracting your angles inside the cosine, then you have a plus in between when you actually split it up with the formula, okay? And conversely, when you have a positive, or like a plus sign, when you're adding the two angles inside, you're going to have a minus sign out here in between all of the terms, okay? So now let's move on to the sine functions, or the sine formulas. So sine of alpha minus beta, okay? So this is taking the difference between two angles and then taking the sine of it. And this is going to be equal to sine alpha cosine beta minus sine beta cosine alpha. Okay, so this one's it looks a little bit more complicated. And then let me just write down the other one here so I can explain that as well. So sine alpha plus beta, so when we're going to add two angles and then take the sine of it, then we can always convert it into this form of sine alpha cosine beta plus sine beta cosine alpha. So again, it's kind of like you only have to remember one formula at a time, because the sine ones kind of come together because all of these terms are the same. Technically, it's just the sign in the middle that changes. And with the sine ones, you can think same sign, right? Because we see for the top one here, for the difference between two angles, then we have a difference also between the two terms on the other side. And for the addition, or the sum of two angles, then we have an addition sign in between here. Okay? So we have that same sign going on. Alrighty? So it just takes practice. I mean, you're always welcome to sit and try to just memorize these at face value, but over time, when you do problems and things, they'll kind of come naturally. Okay? So we can utilize these tools to kind of break up unfamiliar angles into ones that we already know a lot about, such as the following. Let's do an example. Alright, so this problem asks us to find the exact value of cosine 75 degrees. So the first thing is, let's say we draw our unit circle, right? We know this is 0 degrees, this is 90 degrees. 75 degrees is somewhere in here, right? If we were to try to guess the value, we probably wouldn't be too exact at that, right? Because we know 60. We know that one real well. That's like our pi over 3 angle. But 75 degrees, yeah, we're not quite sure about that. So what we can do actually is split 75 up into two different angles being added together. So we could say maybe 30 degrees and 45 degrees. And we see how both of these individually, they're angles that we know a lot about already, right? We know cosine of 30 degrees, we know sine of 30 degrees, we know sine of 45 and cosine of 45. So what we can do is use our sum formula or addition of cosines, basically, in order to break this up and then solve for our value. So when we have cosine and a plus sign in between, we're going to have something, something. We're going to have cosine, 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 right? So we're going to have cosine and cosine again. and cosine again, right? And then that's a 5 there. And we're going to have subtraction sign, and then we have sine of the other angle, of the angles here, okay? Alright, so we'll get something like that, and then all we have to do is just use our knowledge of the unit circle and use these common, or these familiar angles in order to solve the right-hand side of the equation, okay? So cosine of 30, so let me just draw that out here. So we have 30 degrees is here, 45 is here, so cosine of 30 is going to be radical 3 over 2, positive that is. Cosine of 45 degrees is radical 2 over 2, again positive, minus sine of 30 degrees, so sine is going to be the y value, so that would be 1/2, and sine of 45 degrees is radical 2 over 2. Okay, so when we combine all of these together, we just get radical 6 minus radical 2 and over 4. Okay, and that looks pretty exact to me. So that's going to be the value of, this is equal to cosine of 75 degrees. And we can also use these addition and subtraction identities in order to go backwards, kind of, to simplify and solve equations that otherwise would look pretty unsolvable. Such as this one here. So it says to solve this guy, this like monster in an equation, and so before we would have been like, wait, what? You're adding sines and cosines, and you can't use inverse anything because it's just super complicated, and this is really weird. So, but because we know an addition identity, and this looks like, let's see, we have two cosines together being multiplied, two sines together being multiplied, and a plus sign in between. So that means since we have the cosines together, we have to have cosine of something, right? And then this plus sign here, let me actually organize this. So let's put the cosines first. Okay, so cosine x times cosine 2x, and then I just flip these two, okay, just so that we have the cosines in front. It doesn't really matter, you can do it either way. And then we have sine of 2x is equal to radical 3 over 2. Okay, so now that we have it in this form, we could say, okay, so this is cosine of something, and then we have the opposite sign in the middle because it's a cosine. So x minus a 2x, okay? And then is equal to radical 3 over 2. So because we recognize this as a difference formula, then we can do this, and we can just kind of consolidate that into one thing. So cosine of negative x is equal to radical 3 over 2, and we could furthermore, because cosine is an even function, which means this negative sign in front of the x doesn't really mean anything, that equals the same thing as cosine x. This is equal to radical 3 over 2, right? And then we could say, okay, well, now this is just a normal problem, right? Now we'll just take a look at our unit circle and say, okay, when is cosine, when is our x value equal to radical 3 over 2? And that would be at pi over 6 and 11 pi over 6, okay? And then it doesn't really say anything about all solutions or just restricting it to 0 to 2 pi. So because it doesn't have a restriction, an explicit restriction on going around the unit circle once, we'll just list all of the solutions just for good practice. So x could be equal to pi over 6 and then plus or minus 2 pi k, so going all the way around however many times you want. And we also have 11 pi over 6 plus or minus 2 pi k. Alrighty?
Money make it go down.